project, that is a real-time AI threat monitoring and risk assessment system. So as we all know that in this present day and age, the machine learning systems have become very sophisticated, and we are using machine learning systems in almost all the sectors in all the industries, and the application is very vast. So since we are using a lot of machine learning models and AI models, there is a problem of integrity and security. This project is designed to proactively monitor those AI models and AI models for threat threat detection and adversarial attacks like data poisoning and drift input distribution, which can cause real-time damage. So let me go through the project overview and the abstract. So this project is a hybrid, follows a hybrid architecture, and it uses model level telemetric with responsive web dashboards, which include wrapper classes for collecting real time data, and also uses gradient statistics and uses Kafka for data streaming, and it applies concepts such as Bayesian inference, which is used for calculating whether the data is poisoned or not, whether to categorize the data as a threat or not, by using the Bayesian inference principles. And all of these logs are stored on timescale database. And for the front end, I'm planning to use React.js for the visualization, and also on my the plan on my dashboard is for the user to interact with the dashboard. So that's about the project overview, and let me talk about the objectives of the project. So objectives, my project has several objectives, and you can call them as goals. The objectives are, it is used to monitor the gradient and detect the adversarial learning patterns. It is used to detect the input distribution shifts and divergence metrics. So when there is a drastic change in data, and when the input distribution shift changes, that means that the machine learning model, either the data is poisoned, or the data is not available, or the source is not proper. So it might cause problems during training of those data. So it looks through those things. So that is one of the objectives, and it's using the Bayesian inference methods for looking through the possibilities, and it uses the interactive dashboard to visualize it. I'm planning to use a certain color coding like red to indicate that the data is most likely a threat to the machine learning model, and it might affect its performance. And yellow is maybe a moderate data, which we can't say precisely if it's poison data or threat data. And the green data would indicate that it's mostly a, a good data, and it came from a good data source while using this model. And also I want to make this model mostly modular, scalable, and responsive for the user. And coming to the methodology, so this uses a different method approach. From a technical standpoint, I am using a Python wrapper class. This Python wrapper class collects the real-time data of the user, and I'll, I have to make sure that the data doesn't cause any problem with the with the model. So it collects the data without any such problem. So it uses a Python wrapper around it. And the idea is to use agile develop agile development process along with just in time integration, because there is a continuous there is an importance of continuous feedback, which is possible using agile development because it is a faster approach, and it is an iterative approach. So it needs to be upgraded from time to time. So agile development is pretty good with that strategy. And just in time is we the strategy is that we only focus on what is most critical and what's important, because we can't, if we focus on everything, then the time it would take a lot of time. So just this just in time approach integration along with agile development goes in hand to hand, and it's a pretty good strategy for my model. So coming on to the data strategy, I'm using two methods data strategy. Like I've talked before too, I'll be using a real-time data, which is a periodic periodic collection of data using an API call. Uh, let's say if I'm collecting data at 50th data for a periodic time, for a periodic duration. So that's the real time data. And then I would also be taking data from users. So I would be taking data from the experienced users, and taking maybe from 50 or 100 users, and take their feedback from how the data is done. So that's my data collection strategy. So when we go back to the technology stack, the backend is done using fast API and Python to detect anomaly detection and inference. And PyTorch model uses also the Bayesian inference. So I'll be using PyTorch as well. And for front end, like I've mentioned, React.js and Chat Power for interactive dashboards, and Kafka for the streaming data, and timescale database. It's used for mostly logs. And for hosting, I'm planning on hosting on the Google Cloud with Firebase and Docker for development. So that's the technology stack, and that's my plan. Uh, so I've done a little bit of literature review too, and mostly I've done the review of papers wherein they previously, since I don't want to reinvent the wheel, and previously all of these concepts were already done. Some of the concepts I've gone through one of those papers was using a gradient analysis method, and also using a drift detection method, which was in one of the papers. And also there's a anomaly detection pipeline which was developed by Zhang, and I went through that paper as well. And there's also a article on how to make the back end and the front end uh, logic very interactive, usable, and scalable for the users. So I've went through that as well. And when it comes to the architecture, it follows a layered architecture with the MVC principles, so, which is that model wrapper class which collects the data, and fast API is used for handling the backend process, and the front displays it. using the data streaming is done by asynchronous data streaming call for using API calls, right? And that should be it. And then when it comes to the security and compliance, the security is a primary focus and one of the main focus. So the encryption is used for security, and user-based access controls and data anonymization. Not everyone can access this, and there's in order to get an access of data, there's also role based access, so they have to log in, either if it's a admin or if it's an engineer, only then he can use it. Other than that, they can't use it. And the encryption is maybe I'm planning to use TLS 1.3 uh, security. So that is what I'm planning. And ethical considerations. Uh, so ethical considerations are, one is the data privacy, which is very important. So all the data, as we have spoken earlier, is encrypted, and and it is a user based access, so no one gets the access to it unless it's admin, or if it's a programmer, developer for that, and only in that case they might get the access for it. So it's role based, so no one gets the access for the. And the bias in the algorithm is, it's in all fairness, the evaluations used are balanced data sheets and reduces the bias. So all of the data sets um, are pretty fair, and they are random and fair and accessible. It's WCAG compliant. It's a keyboard accessible, screen friendly reading, and inclusive of all users. Some of the constraints are that the time and resources. Uh, these are limitations and constraints, since the timeline is pretty less, and access to high performance GPU is required for these models, because it needs a large amount of data to get trained. So high performance issues might occur, and also the timeline. Next is the scope. Uh, Scope is it is fully compliant and audit testing. And technically, and another limitation is technical complexity. So integrating the telemetric anomaly detection and risk scoring under latency is it's a tough task to consider. And when it comes to testing and validating, unit testing is done, verified component behavior, and then there's integration testing and usability testing, which is usability is testing is done through the real world feedback, when a user uses this model and he gives us the feedback of how it's coming. And then there is load testing, which is like simulating with lot of data and what lot of volume request, and how the system copes up with the model. And then there's security testing, as uh, we have seen the privacy and security, and if it's the data is secure, or if it is integrated, so that testing is also done. That's for the testing part of it. And then development is managed through GitHub CI/CD pipeline, and it is hosted on Google Cloud via Firebase and Cloud Run. And the crash reporting and the performance logics logging tools like Crash Analytics and Google Cloud Logging are used.